All right, and our first lightning talk today is Brandon Bennett from Facebook with automated network provisioning.
Good afternoon. My name is Brandon Bennett. I am a network automation engineer at Facebook. And one of the areas that I've been concentrating on for last couple of years is how we can automate the provisioning of our networks. So I'm going to go through a brief history of what we've done so far, and then jump right into where we're actually going and what we've developed to help with some of the problems that we've had in the past. So in the past, I actually looked at the Git history for the service that we've used in the past, and it was actually committed to 10 years ago. And if you can imagine where automation and networks was 10 years ago, there wasn't zero-touch provisioning, there wasn't any of these newer technologies. So how do you automate that? Well, you do exactly what a human does. You get out your laptop, you plug into the console port. So the system was actually based off of that. So we had our provisioning servers, or a server or servers, that would actually SSH into console servers and then screen scrape consoles. We actually still have this running in a limited fashion today. It's amazing that it works the way it does, but you can imagine screen scraping is not necessarily the most ideal way of handling things. We've also ran into a couple other problems the way that this system was designed. It was designed to provision a device in the context of a job. So a job would be kicked off, that would be stored into the database. And then all the provisioning aspects of that device was handled inside that job. And there's a lot of things that happen besides just applying a configuration and applying a config to it. And I'll get into that a little bit more. The other thing that we kind of ran into is, as we designed the system, it was designed to actually handle only top-of-rack devices initially. And that worked so well, we started adding in fabric devices. And that worked so well, we started adding in backbone routers. And you can imagine that if you have this code base that started off as something really small that wasn't planned to be extended to the extent that it was, there's conditionals spread all over it. You'd make one change over here, and it would break something over here. You'd fix that change, you'd break the third device. So it became pretty hard to try to reconcile. It was also very slow, because you can imagine actually pasting in a configuration over 9600 baud was extremely slow. Everything was done very serially. We do this, we do this, we do this. We also did like LLDP discovery during this process. So we would show LLDP neighbors, try to figure out what the device was. And so we needed to solve this. So it's not always a good idea to rewrite something just to rewrite it, but we were actually running into some issues. So if anybody follows Mark Zuckerberg on Facebook, you'll probably notice that there has been a couple announcements for data centers in the last year and a half. So these are 5 new data centers that we're announcing. There's multiple buildings going into each one of these regions. There's a lot of switches that need to be updated for that. So I'm sure everybody out here is actually asking yourselves, why not just use ZTP, right? ZTP just solves this problem for you. Most of the vendors now have pretty good support for it, that it should just work, right? Well, the problem is, like, ZTP is the right base to base your provisioning automation on. The problem is that there's so much more to automating a device than just getting a config and code on it. So code generation is actually a very large part of this, or a config generation. You need to find out, somehow map back that this serial number or this chassis goes to this config. You need to be able to generate that config. You need good modeling for your circuits and for your other device configuration. After you get done applying the code and configuration of the box, you need to verify that the box is ready for service. This includes power supply checks. You've got redundant power supplies, make sure they're both on and operational. This includes optical checks, make sure that your DOM levels, your light levels are good. Fans are spinning, things like that. And you also need to set up alarming and alerts and get your box into your inventory management systems. And usually there's a flag to enable that to go into production. We also, if there's a top of rack device, will automatically kick off server provisioning as well. As soon as the top of rack device is provisioned, go ahead and do the servers next. There's no reason why that needs to be a human to come in and do that. And the other thing is ZTP only handles the initial configuration of a box. There's other lifecycle operations that we need to be able to handle. That includes upgrades, reconfigures, like complete reprovisions, and decoms as well. So we needed a system to kind of handle all this. So ZTP on itself, that little blog article on Arista's website wasn't enough. So here's what we came up with. It is a ZTP-based solution. So we started off with that. We already used the Kia DHCP servers for Pixie booting our server environment. So we're able to hook into that. Kia actually allows you to have plugins written in C++ that hook into our backend systems. So we could actually assign the real IP address directly to the box, the real management IP address that it would have anyway. And inside that DHCP offer message that comes down to the box, unfortunately, this is only IPv4 at this point. In that offer message, we actually, instead of providing a configuration to be applied to the box, we actually download a Python agent, or a little Python script that we call an agent. And the reason why we do this is there's not a whole lot of visibility when it comes to running ZTP on a box. You plug it into the network, it runs stuff. If you're plugged into the console, you can see logs scroll by, but that defeats the purpose. So we have this little agent that will actually look at the logs coming off from the ZTP process, and it will stream that off to this gateway. It will also find out exactly what files need to be downloaded and what config needs to be applied, and in what order. We sometimes also write software that runs on these devices, so we need to download those RPMs or download those packages and install them at this time as well. The ZTP gateway is just a really simple REST gateway. The reason why we're using REST at this point, we're not a big REST shop. We don't use it anywhere else. The only reason why we're doing it here is because we want the agent to be extremely lightweight. We don't want to try to package third-party dependencies. HTTP clients are part of the standard library in Python, so it's very easy for us to just utilize URL-lib in Python for that. Then there's actually a controller that kind of controls the entire job. This is really the interactions with the database so that we can log, to insert the log messages into the database, as well as the current status of the provisioning job. And then for all that other stuff that is not covered by ZTP, all the audits, all the checks, all the additional steps that we need to do after or before provisioning starts, we created this this queue-based system where we actually split everything up into steps. We utilize Zookeeper, Apache Zookeeper, to create a simple queue, and then we have a number of executors that actually run these steps as they come in. So it's a simple job queue system. Really quick on the steps, we really looked at having one big, what we came from, which was having this one big binary that had a bunch of conditionals in it that kept breaking. The blast radius was huge. Every time we had to make a change to our provisioning system, we risked taking down provisioning somewhere else, and this was happening too often. So we actually really wanted to solve that problem here, and we created steps as really small standalone programs. For the most part, these steps are less than 200 lines long. They could be written in any language. We actually made the steps where they're just an executable that takes an input from standard in and outputs logs on standard air. So it's we can plug in whatever we need to do. So as Facebook needs to change to different directions, we can do that. And then we wanted them to fail really, really fast. If there was a problem, we wanted the program just to exit with an error code that wasn't 0, and then allow the system to automatically restart. There was a lot of instances where we would fail an entire provisioning process because one little thing was wrong. A good example of this was power supplies. We'd have dual power supplies in a box. We were doing the checks way at the end of a job, so we're putting on a config, we're doing all this work, and then way at the end of the job, we're checking for power supplies. Whoops, one of them's not plugged in. Fail the entire job, start over from scratch. That wasn't working for us anymore. So now we can do power supply checks and retry them over and over again. In fact, we can retry forever if we wanted to. Or we have another option where we can bypass one of those steps. Bypassing it will actually open ticket in our ticketing system to somebody actually to, I guess, automate the humans, as I put it, to go take a look at why that power supply is failing, but still allow the servers to be provisioned after that. So don't block us on that. And then we can define what steps are being ran based off the role or the actual model that we're, the hardware model that we're actually operating against. And so finally, I just want to say thank you for having my talk. Here is my team that put this together. This is actually at our Ireland data center that just got turned up this summer. As you can imagine, they were still doing construction as we were provisioning devices with our new system. Thank you very much.